Good day everyone. We will be talking about what is protocol. Computer communicate using a common set of rules called protocols. This rule ensure that devices can understand, send, and receive data properly. Protocols are like languages. They define how computer talks to each other. Without them, communication between devices from different brands or systems would be possible. Another definition of protocols. Network protocols are formal rules and standards that define how data is transmitted across network. They specify how data is permitted, how it is sent and received, and how errors are detected and corrected. Think of protocol as a traffic rules for the internet. They control how message move from one devices to another to avoid confusion or data loss. Using our Cisco packet tracer setup as shown in the diagram, in this network we have two switches in the middle that connected together. Each switch is connected to 4 computers, PC 0, 1, 2, and 3. On the left side, the PCs 4, 5, 6, and 7 on the right side. So this network represents a simple local area network, which is LAN, where computer exchange data following specific communication rules, also known as network protocols. So in our message encoding, before data can be transmitted, it must be encoded into signals that can travel through the network medium. In our Cisco packet tracer setup, the PC send digital data in the form of binary codes, 1 and 0s. The network interface card of each PC convert these digital signals into electrical signals that travel through the internet cables connected to the switches, and the receiving end, the switches and PCs decodes this signal back into the binary data for processing. So this ensures that both sender and receiver interpret the data correctly. Like, for example, when PC0 sent a message to PC5, the data is encoded by PC0 and IC transmitted through the switch connection and decoded again by PC5 to make the message readable. In message formatting and encapsulation, each message must follow a specific structure so that the receiving device can correctly interpret it. This process is called encapsulation, where data is wrapped in layers of protocols information such as IP address, MAC address, and error checking codes. Protocol also define the maximum size of data that can be sent at once, called the maximum transmission unit. In internet network, the MTU is typically 1.5 bytes. If a message is too large, it is divided into a smaller packet transmitted separately and received by the receiver. Example, if PC1 sends a large file to PC7, the file is split into the packet by TCP sent across the network and then reassembled by PC7 once all packets arrive. The message timing is timing determines when data is sent, how fast, and in what order. Protocols manage timing to prevent network congestion and data collision. In our LAN, the switches use CMS-MACD, which is carrier sense multiple access with collision detection to control transmission timing. If two PCs attempt to send data simultaneously, the switches detect the collision and make them wait for a random time before retrying. Example, if PC3 and PC4 send messages at the same time, the switches coordinate timing to avoid conflict and ensure smooth delivery. In message delivery option, protocols also specify how data should be delivered. Its unicast is 1-to-1 like PC0 to PC5. Then multicast 1